Here's an interesting looking balance with a couple of rocks, and we are on chemical equilibrium, and this is part 3. And as per usual, I am Ms. Bedrosian. Yay! All right, we are going to just do an example this time. Here's our little science cat, and he is going to say, let's do an example. That's what we're going to do. Here is the equation. 2NO plus 2H2 in equilibrium yields N2 plus 2H2O. Assume that they are all gases. So a 1 liter vessel contains a mixture of 0.10 moles of NO, 0.050 moles of H2, and 0.10 moles of H2O. You can figure out the molarity. At equilibrium, we know the concentration is given to you of NO, and that is 0.062 molarity, capital M. So what we have to do, we have to find the concentrations of everything else at equilibrium. And we also have to find the equilibrium constant, which is noted as K sub C. So for this, we're going to learn how to create a table. We'll be using this type of table many times over. This is called the ice method. And the first thing that we do, there's some ice cubes, is that we will create the table by using our balanced equation. So you put the balanced equation down first. There it is. Kind of spread it out so you can put the numbers underneath it. It's kind of like a grid. On the side here, we have initial, means what are their concentrations at the start. The change in concentration, how will it change? And at the end, what those concentrations are at equilibrium. Can you see where the term ice method comes from? So let's take a look at the data that we have. I gave you some numbers. It was 0.10 molarity, well, moles, but you can figure out the molarity. It was in a 1 liter vessel for NO. And it was 0.050 molarity H2. At the beginning, there was no N2 at the start, but there was some water that was given to you at the beginning. That was 0.10 molarity. So these are the initial concentrations. The change, that would be, we know the ending molarity for NO. So this is going to go down by 0.038 molarity. Since this is 1-to-1 with NO, this means the change here is the same. It's going to go down by 0.038 molarity. N2 is 1/2 of NO, so it's going to gain 0.019 molarity. We're getting this from the balanced equation, like a little stoic thing. And this is twice that, so it's going to go up 0.038 molarity. So at equilibrium, find the differences. This is 0.062 molarity that was given. This one, you're going to minus that number there, and you will get 0.12 molarity. This one started at 0 and goes up, so you'll get 0.019 molarity. And this gets added to the start, and you will end up with 0.138 molarity. Now we have equilibrium. Now give me the equilibrium expression. And here it is from the balanced equation. Easy enough, solve for K. And when you do that, you get this answer. 7.0 times 10 to the second. No unit. And this is the end of part 3. Still lots more to read in that chapter, but this is the end of the lecture part. Here's an interesting looking balance.